Hello, hello, friends. 68% of you that watched my last video are not subscribed, which is totally fine if you don't want to be, but maybe you thought you were and you actually aren't, and you wanted to double check. This might be a good reminder, because I've never, ever watched channels for years and then realized I wasn't actually subscribed to them. That'd be wild. That definitely wouldn't happen. You wouldn't want that to happen to you, you know? We have today more puzzles where I have to figure out why they don't work, why there's no solution. I just spent like an hour and a half on another puzzle and I got to the end where it's just Sudoku and I'm so stuck. I cannot figure out where to go. So also a reminder that later today, the day that this is posted, later today, I'm doing a Sudoku stream. So we have some good puzzles for that where I would love to get some help from chat, figure out where I'm going wrong. But today we have No Solutions Between Lines by Twototenth. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. Between lines. The digits on the lines must be strictly in between the digits filled in the circles, excluding the digits in the circles. Okay, so normally how this would work, if this is a 1 and this is a 4, I'm petting Loba with one hand, then this would have to be a 2 or a 3, this would have to be a 2 or a 3, this would have to be a 2 or a 3, and this would have to be a 2 or a 3. So why does this shape not work? The digits on the lines must be strictly in between the digits filled in the circles, excluding the digits in the circles. Okay, so whatever this is, and whatever this is, has to have 1, 2, 3, 4 different numbers between it. So if this is a 1, this is a 2, 3, 4, 5. This would be a 6, 7, 8, or 9. Can I think about it that way? And then if this is a 6, 7, 8, or 9, these don't have to be different digits. These two have to be different. What's going on, buddy? She says, you are not petting me enough. Use both hands, apparently. Let's do this. If this were to be a 1, and then this is 2, 3, 4, 5, this is a 6 at a minimum. Have to be a 6, 7, 8, or 9. If this is a 9, and this is 8, 7, 6, 5, this would have to be 1, 2, 3, 4. So I kind of have like a low-high situation going on. If this is a 9, and this is an 8, and this is a 7, and this is an 8, and this is a 7, this could be a 6. This could be a 6. Or anything lower than that. It's like a 1, 2, 3, 4, 5, 6. If this is... Am I thinking about that correctly? Yes. If this is a 6, though, this could be 7, 8, 7, 8, and this could be a 9. Okay, that's a lot of options for that one. I do also know that I have to have, like, these are all different because they're in a line, these are all different because they're in a line. These are different because they're in the same region. These are all in the same region. Do I have to go, like, low, high, low, high? What's wrong with this being a 1, a 9? Or, like, 1, 6, 9? That seems fine. But whatever this is... Oh, wait, this doesn't have to be 1, 2, 3, 4 also. This could be, like, a 6, 7, 8, 9, and this could be low. Hold on, how do I want to think about this? These are progressively harder, and I did the easy ones in a different video. These are 4 different numbers between this and this. This is at least 2 different numbers between these two. This is 4 different numbers between this and this. What is 4 different numbers between this and this? This is 4 different numbers. This is 4 different numbers. These are 2 different numbers. These are 2 different numbers. So what if this is a 1, 2, 3, 4, 5, and this is a 6? This can't be a 1, 2, or 6. This could be a 3, 4, 5, or a 7, 8, 9. Okay. If this is a 6, we did say this could go 7, 8, 7, 8, and this could be a 9. Or it could be something lower, like a 6, 5, 4, 5, 4. This could be a 3. So this would be like a 2, 3, 9. It can't be a 1 because of this. This could be 9 and 3. 4, 5, 6, 7. Uh-oh, what if I think this works? 4, 5, 6, 7. This would be an 8, this would be a 7, this would be an 8, and this would be a 7. Am I not allowed to repeat digits? What if I think this works? 1, 6, 2, 3, 4, 5. 6, 9, 7, 8, 7, 8. No, because a long time ago, very early on, I did a between lines puzzle, and I got so stuck until somebody pointed out, you can repeat digits. Why would you not be able to repeat digits? The rules don't say you can't repeat digits. And I remember that because that was the first sassy interaction I had with somebody. I was like, what do you mean? 3, 4, 5, 6. 3, this could be a 4, this could be a 5, this could be a 6, this could be a 7, this could be an 8. So even if I don't repeat digits, maybe I don't understand this one. Maybe, okay, so the way I read this and the way I understood this, it works, it's fine. Well, maybe this breaks something else off the line. Like maybe, oh, now there's nowhere for 4 to go in here or something like that. That could be. I didn't think about that. I wasn't thinking about stuff off the circles. Because now this can't be a 1, 2, 3, 4, 5, 6, 7, 8. This would have to be a 9. What goes in here? 1, 2, 3, 4, 5, 6. Where does 8 go in here? Where does... Okay, 7 has nowhere to go in here. Okay, so thinking about stuff off the line. 7 has nowhere to go in here. Okay. Let's go back to our example with repeating digits. I wanted to do like 7, 8, 7, 8, 9. And then this could just be like 7, 6, 5, 4, 3. And that's fine. Where does this digit go in here? Whatever numbers I have on the line, this digit needs to go in here somewhere. It can't go on the line. It can't go here because of Sudoku. It can't go on this line. So this digit has to go here somewhere. Okay, that's a good way of looking at it. That's a good way of looking at it. Let's do this. Whatever digit this is goes here somewhere. Whatever digit this is has to go in here somewhere. It can't go here. It would go here somewhere. Okay. Whatever digit this is needs to go in here somewhere. It needs to be different than red. So orange would go here somewhere. Red also needs to go up here somewhere. So red would have to go here, but also orange has to go here. That's why it doesn't work. Okay, it's the stuff off the line. Whatever this digit is needs to go in this region somewhere. It can't go on either of these lines, and it can't go here because of Sudoku, so it must go here. I know that this circle digit is different than this red one, because I need to have numbers that can go between them. Orange needs to go in here somewhere. Can't go here, can't go on the line, so it must go here. I need orange to go in this region as well. Can't go here, can't go here, can't go on the line, so it has to go in the corner. And I'm stuck with the same issue as red. It's the stuff off the line that breaks it. That makes sense. Okay, next one. No solutions. Region some lines by Malrog. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. For each and sum lines, blue lines are split into segments by box borders. Within each individual line, the sum of the digits on each segment is the same. The sum of segments on different lines may or may not be equal. So this has the same sum as this, and this has the same sum as this. So there might be something nifty, like if this whole thing has to sum to 45. Let's do this. Let's do this. Whoops, nope, sorry, that's red. I want to change the colors. And this is green, right? So this sums to 45, and this sums to 45. So green plus pink plus orange plus blue sums to 45. Green plus orange plus pink plus blue sums to 45. I cannot have 4 different cells equal 1 cell. This would be 10 at a minimum. And this is 9 at a maximum. If these have the same sum as this, and these have the same sum as this, green has the same sum as green, this is 45, and this is 45. Nice. Nice. It is because blue can't equal blue. There you go. Neat. No solutions palindrome. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. Palindrome lines. Digits filled into the lines read the same forwards and backwards. Okay. Oh, I forgot Tyrgannus. I forgot to say the name. So this and this would be the same. Let's use colors. My number pad is on letters for each one of these. I don't know what I did. These would be the same. And they all need to be different. This cannot be yellow, but it could be red or orange. This needs to all be the same. It could be red or orange or yellow. This needs to all be the same. This needs to all be the same. This needs to be something. Where does red go in here, maybe? Red would go here somewhere. So if red was on this line, this would have to be red. If this was red. Same thing with orange. Orange needs to go in here somewhere. I can't also have orange on this line because orange would also have to go in here. So I would need a new color here. Same thing's going to happen with yellow, so let's make this one green. Orange would go somewhere here, yellow would go somewhere here, green would go somewhere here. For the same reason, this can't be orange or yellow or green, so let's make this one blue. So green and blue would go here. I'm not looking at this correctly. Maybe... Where do these 3 digits go? Whatever they are, these 3 are the same as these 3. So I need 3 spots for red to go in here. I kind of have roping. Something about how you can't have vertical and horizontal roping, but I don't really have roping. Okay, wait. I know that these 3 digits have to go somewhere up here, and they can't be these 3 digits. One of them could be the same, but then the other 2 would have to go here. Okay, I can do this better. From what I had earlier, one of these digits can go here. So if these digits can't go here and only one of them can go here, 2 of them are going to go here. Which means they'd end up being the 2 digits, let's say it's orange and yellow, would end up being here. Why is that bad? Why is that bad? Am I not looking at this? Should I be looking at this? Let's say red goes here again. Let's put that back. This can't be orange or yellow, so let's make it green. And this can't be red or green or orange or yellow, so let's make it blue. Orange and yellow need to go in here somewhere. They can't go here, they can't go here, they can't go here. So orange and yellow would be stuck going here somewhere. They need to have a spot up here to go, so they're going to go here. Meaning this is going to be orange and yellow then. But then this way also, red goes here, orange and yellow needs to be here. Oh, there you go. I can clean that up and I can explain that better. No matter what these are, really. If this is red, orange, yellow, red, orange, yellow, these 3 digits. How can I explain that better? Up here, they're gonna have to go here. Over here, they're gonna have to go here. I don't, sorry, like this. I don't want roping. Because you can't have both vertical and horizontal roping. So one of these does need to have to go on here as well. But then that also causes problems. I can only have one of these 3 colors on this one. And then orange and yellow doesn't have anywhere to go. I have to squeeze them both into here. I think that's the best way I can come up with to explain it. If I don't put red on this line, red, orange, and yellow would go here. And then red, orange, and yellow would have to go here. But that won't work because of this. So that means I do have to put one of them on this line. Let's say it's red. Then orange and yellow can't go on this line because that breaks this region. So I have to put orange and yellow here and here. But then that breaks this region. Orange and yellow can't go here, can't go here, can't go here, and can't go here. Orange and yellow would have to squeeze into here. I think that's the best way I can explain it. I'm not sure how else to word that. Besides, there's just not enough places for orange and yellow to go at that point. I can't have both vertical and horizontal roping is an issue, I did notice. I could probably come up with a more concise way to explain that. I'm not really sure. No solutions, German Whispers, Arrows by Palfly Kampling. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. German Whispers, adjacent digits along the thinner green line must have a difference of at least 5. Rinband, digits on the thicker purple line form a set of non-repeating consecutive digits in any order. So German Whisper would go high, low, high, low, high, low, high, low, high, low, etc., etc. Can't use 5s at all. And 4s and 6s you have to be careful with. Rinband, digits on the thicker purple line form a set of non-repeating consecutive digits in any order. So this would be 4 different numbers. 4 different numbers that can't go here. So can I do something with this? I know that red and blue, I should explain this. Red and blue will have the same numbers, and the shape seems like that'll come in handy. Okay, so these 9 cells, I can explain that better than what I just did. If this is a red section and this is a blue section, we have a red box and a blue column. Each of these have the numbers 1 through 9 once each. Wherever they are, they contain the same set of digits to choose from. So they're going to have the same numbers, they're going to have the same sum, etc., etc. We can overlap them like this and say these 3 digits are the same digits for red that they are for blue because they share the same cells. So if we cancel them out, then these 6 red cells are the same digits as these 6 blue cells in whatever order they are. We can keep that going and we can have multiple sections. So if we say these 2 red sections and these 2 blue sections, these 18 red cells are going to be the same sum as these 18 blue cells. They're 2 1s, 2 2s, 2 3s, 2 4s, etc. They're the same digits, they're the same sum, they're the same. If we overlap them again, maybe we do this column and this column, and we cancel out these 6 cells, then these 12 red cells are the same as these 12 blue cells, etc., etc. And we can go even further with it. If we have these 4 red sections, and we have a blue line here and a blue line here, so that this cell is actually 2 blue, and this blue line here, so this cell is 2 blue and 1 red, and this line here, so that each of these corners is actually 2 blue and 1 red, and we take out the ones that cancel out, like this. And then in these 4 corners, we take out 1 red and 1 blue, so we're left with 1 blue. We know that these 16 red cells are the same as these 16 blue cells. There's an easier way to get that shape without doing the corner blue. I can never remember what it is. I think it might be something like this. Whoops. These 4 red sections are the same as... It's this, isn't it? 1, 2, 3, 4, 5 red sections. And 1, 2, 3, 4, 5 blue sections. And then take out the ones that cancel out. That's an easier way to see it. I can never remember that one. I always just think of the crossing one. But there's 2 different ways to show that these 16 red cells are the same as these 16 blue cells. Okay, so I feel like I should use that. If these are 4 different numbers, of course, they're in the same region. They're consecutive, they're non-repeating. These need to go in here somewhere. This is going to be high, low, high, low, high, low somehow. High, low, 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 high, low. Yep, that works. That pattern works. I could use 4s or 6s. They would have to be on a corner. What are my options here? 1, 2, 3, 4. Oh, either way, I have to use a 4 or a 6. There's no way out of it. 1, 2, 3, 4, or 6, 7, 8, 9. I don't want to use both a 4 and a 6. Because I just showed that the corners have the same... Like, all of the corners are either high or either low. I do definitely have to use a 4 or a 6. I don't want to use both. So this could be 1, 2, 3, 4, or 2, 3, 4, 5, or 5, 6, 7, 8, or 6, 7, 8, 9. Why can I not use these in here? Let's place some digits. If this is a 1, let's say that these are 1, 2, 3, 4. I know that these can't be 4. And I have to use a 4. Let's say that this is 1, 2, 3, 4. Oh, that's why. That's why. Well, ooh. Whatever digits are used here have to go in here. So that wasn't really why. And this is 6, 7, 8, 9, where I can't use any sixes, actually. What if the German Whisper is just broken on its own? This can't be a 6, 7, 8, 9 with this setup. Okay, it doesn't matter if the corners are 1, 2, 3, 4 or 6, 7, 8, 9. It's gonna have the same effect. The corners are either low or high, and then these inside parts are the opposite, either low or high. So this won't be 6, 7, 8, 9 because I can't put a 6 anywhere. It also won't be 5, 6, 7, 8 because I don't have a. Oh, I can't use a 5 here. It is broken. Okay, I see. I can't use a 5 in here. This can't be 2, 3, 4, 5 because you can't put a 5 on a German whisper line. So with this setup, this would have to be 1, 2, 3, 4, which also means I can't put a 1, 2, 3, 4 here because of Sudoku, so it's broken. That's why. That's why. That's why. I can't use a 5 on here, so this strictly has to be a 6, 7, 8, 9, or a 1, 2, 3, 4. Whichever one it is, it definitely includes a 4 or a 6, which has to go on a corner, can't go anywhere else. And then so this ends up being broken. What if this is not... Nope, it doesn't work. It doesn't work. I need to have 4 different low numbers or 4 different high numbers because of this. So that must include a 4 or 6 where it would have to go in the corner, and that ends up being broken. Nice! Nice! That's what it is. That's what it is. Very cool. Very cool. That's the last puzzle I have of these. But these are very nice. They made me think. Oh my golly. What do you think, Luna? Are you here to yell at me some more? She wants to go to bed. It's not bedtime. Very cool. Let me know how you did on these or if there's another way to see any of these. Very nice.